It's right here, right?
Okay. Horrible children. So, with these two questions, alright? My issue, have you got the booklet? Can you get that booklet out? That's what we're working on. Right, so we've got a line. Now this starts up with the kind of situation when we're dealing with the standard form of the equation. Alright, so we are told to draw a line and we're told these 2 points. Now, do you remember I showed you with that other on here? Alright, what did this point up here represent? On the red line. What?
There were children or there were donkeys?
Okay, but more specifically, you're right, the number of children, number of donkeys, but how many children?
27.
X was children, Y was donkeys. So this point here, okay, this point here represents how many children? 0. And how many donkeys?
43.
So what we can say is, in this case, the y-intercept, all right, the y-intercept is the number of donkeys when you have no children. What does the x-intercept represent?
The amount of children when you have no donkeys.
Exactly, and that's something to keep in mind. So let's go back to this, and this is the skills we're looking at. So you are just being asked now just to sketch the graph given the intercepts. So, are we all doing this?
Yeah, I did.
So, x-intercept is -2. So we should have a point. The x-axis intercept is -2. The y-axis
It's -2.
-2. And we should draw a line. Okay. The next one then.
Okay.
X-intercept of 5. Y-intercept of 4. We draw a line. Okay.
I got that too.
Good. Right. Now what we need to look at though, if you're all happy with that, right, not everyone has reproduced those on their page yet. So let's have a look. So I asked you to look at this one. And I asked you what it was called. So you have now learned standard form. So we should write that. So this is standard form. Okay. Did you all find it in your textbook or did you all ask Tally?
No, I found it. We used to put the wrong one.
Mr. Cunningham told you. Okay, this morning.
Yeah, he did.
Well done doing your
No,
homework.
but you should actually found it in the book.
Good, okay.
And then I copied my
Right, what I need to do then, we've got 2 ways to sketch this line. One way, which we'll look at in a bit, is to rearrange it so we put it in gradient intercept form, okay? But what we want to do first is, because it's good to deal with it, as you've seen from the children and the donkey problem, it's actually quite good to be able to draw the line just from that form, from standard form, okay? So, this is what we're going to do. When we say 3x plus 4y must equal -12, x and y must be coordinates that you can use that would fit into that equation. All right? So I should be able to pick a number for x and a number for y, and when I do 3 lots of the x and 4 lots of the y, I get the answer -12. And the clue for how to do that is in the previous 2 questions. And what we try and do is we try and find the axis intercepts. And there's a reason for that, because quite often it's the easiest point to find. So for instance, if I try and find the y-axis intercept, what am I saying again? Which coordinate is what? Think what I said about the children and the donkey. So if the y-axis intercept, which one of the coordinates is 0, which one is it? Which one, x or y? No.
X.
The x coordinate is 0. Do you remember on the y coordinate, that was when the children were 0. So we were how many donkeys? And donkeys was the y value. Right? So on the the y-axis, we can say that the x coordinate equals 0. Always, yeah? And actually, that's something else we're coming to. That is the equation of the y-axis. What do you know about the x-axis then? It's y equals 0 because the y coordinate is 0. You might want to write that down now. Okay? I'll give you a little breather to write that on your diagram. Okay. Now, here's the thing then. If I want to know where the line crosses the x-axis, I'm looking for where the x coordinate is 0, yeah? So I need to work out what the y coordinate would be. So, if 3 lots of 0, what would 3 lots of 0 be?
0.
0. So if I do 3 times 0, because x is 0, plus 4 lots of whatever y is. So I'm trying to figure out what would y be equals negative 12. So that's 0 plus 4y equals negative 12. So I can forget that and just say 4y equals negative 12. So what must y be?
Negative 3.
Negative 3. So I know that my y-axis intercept is at negative 3. Okay? Get it? So what I've done is I know that x is going to be 0 somewhere, and I've tried to figure out what y would need to be. So what's the next stage then? I need a second point. So I don't know the gradient because I've not got it in that form. The gradient is not 3, by the way.
Oh, so now we have to find out.
Go on. So we found out the y coordinate by...
find out the other way now.
What do you mean the other way?
Like, we just found, I'm pretty sure we just found out what y is.
We found out what y... Yeah?
Now we have to find out what x is and y is.
Perfect. So we would do, instead of 3 times 0 plus 4y, we're going to do 3 times x plus 4 times 0 equals negative 12. So this is when x equals 0, and this one is when y equals 0. So we're now looking for the x-axis intercept. So we've got 3x plus 0, so we've got 3x equals negative 12. So what must x be?
Negative 4.
Negative 4. So that will be, x must be negative 4. And do I have enough information?
Yeah.
I do. Yeah. So draw those. Use your ruler. Make sense? Now the next one is going to be, please stop singing. Next one will be a bit more difficult, but I'm going to let you have a go at yourself. You might decide that actually 0 doesn't work very well, but try it, see what I'm saying. Have a go at this next one. You're using the same principle. See what you think. Have a go at it. I am recording, by the way, just so those people being silly know that. Yes. Let's go through this one then. Tyler, have you got it?
Yes.
Right. I've got a bit more space with this one. So you've noticed that for this one, if I make x equal to 0 and I find the y-axis intercept, if x equals 0, I've got 5 times 0 plus 3y is negative 6, which I can forget about that.
Negative 2.
And then say y is negative 2. So that means this one is here.
Like x don't.
Right. So if I do y equals 0, I've got 5x plus 3 times 0 equals negative 6. Forget that, so I've got 5x is negative 6, which means x is negative 6 divided by 5, which is not wrong. It is exactly that. But, as Safi was telling me, it's very hard to graph that. We don't have the ability to graph that on this paper because we don't have the level of accuracy in our graph paper that we need. If we did, we could graph it, no problem. So we actually, there's nothing wrong with what we did, we just need to find another point that is more appropriate. Okay? Did anyone find one that is more appropriate? Tally.
Do I do the point or the thing I time?
Yeah, what did you choose for y?
Okay, I chose to time by 3.
So she chose to do 3. Y being 3. So this is the same process. I'm not saying whether we're right or wrong. Well, it's the same thing as making y equals 0. I'm still looking for the x value that works when y is 3. And there will be one. It's just whether it's easy to graph or not. So let's just check. So we've got 5x plus 3 times 3 this time has to equal -6. So that's 5x plus 9 is -6. So how do I solve this? You all know how to do this. Pardon?
Minus 9.
We minus 9 and we get 5x. If we take away the 9,
Equals -15.
does equal -15. Yeah?
What?
Is that now a situation that's better? So now I've got x must be -3. So now we have a point. We said when y is 3, x must be -3. So -3, 3. So that's the other point. So it wasn't an axis intercept we used, it was another point.
How did you get
3 times 3. Again?
Because y is 3, and I've got to use 3y. 3 times 3. 3 times y. Yeah?
Wait, where's... Oh, right.
Yeah?
Don't
get confused because they're both 3's. I've got to do 3 times whatever y is.
Right?
If y is 3, got to do 3 times 3.
And then how
Yeah.
did you get 9 minus 9?
Because I've got 3 times 3 is 9. So I've got 5x plus 9 is -6. So as Tally said, to solve that, like we did in our algebra unit, subtract 9 from both sides,
Oh.
gets rid of it.
Okay, so that's not 9 minus, like, I thought
It wasn't part of the first bit, it was part of my
that makes
working
more
out.
sense.
Okay? Alright, so we've got that point. So now, we have enough points. I can hear conversations that aren't anything to do with my math. And there's my lines. Daniel, all your sheet is lacking lots of lines. Alright, can you see how that works?
No.
That's because you've been dozing off. And you've just put your sheet under your book.
I already did my book.
No, I want you to do it on the sheet, that's why I gave it to you. Right, so you can plot the graphs, even the ones you've not done yet. Okay.
Let's all start.
This is all on this sheet here. So we're doing that one, yeah? The sheet that you're looking at, all of this you're missing on your page. Right, yeah. So we've got these. You now have some more to do on the next sheet. To practice. Alright? You've got these 2. Do them now. You've got 2 minutes. And whatever you haven't finished, you can do this for Monday.
But just these 2?
Those 2, yeah. You've still got 2 minutes.